Right. Yeah, guys. We'll be starting with one question today. Moreover, we'll be discussing one data structure, but of course, before reading it, we should know the need of it. Is it right? Okay. So let's discuss the question first. An array is given. To be more specific, a string array which contains strings is given to us, and on that array, we'll be asked multiple queries. And it is specified that for each query, we'll be giving one input PS. Yes, that will be of type string itself. Don't get confused. That will be of type string itself, PS. What we need to do for every query, we need to count number of strings that are actually starting with PS for every single query. Yes, let's try to understand with example. You have array in front of you. There are three queries. In the first query, I'm saying PS is nothing but AB. Yes, that means what we want is all the strings in this array which are starting with AB. The starting, is that right? Not in the middle, not in the back. They should be starting with AB. So in this, we just want the count. Is that right? What will be the answer in this? It will be one. There is only one string. For the second query, if I say there is A, which is PS, the answer for this it will be 2. Is it right? Which are these two strings. If I say there is a PS where ABC is itself the PS string, is it right? In this, what will be the answer? One. One itself. Yes, that means one entire PS can also be one entire string. Okay. So question was it should be clear. If there are three queries, these would be the answer. Of course, we have to return an integer value. We have to print a number. That is nothing but the count. The first idea, first thought, how can you solve this? First approach.
Iterate over the given array and check uh, how many strings.
Yes, yes, we can simply say just for every query. The first thought that everyone should be getting for every query, we can simply say whatever the PS is there, is that right? In this example, PS was, let's say, AB. Let's take the first example itself. If PS was AB, what we'll do? Go to the first element, which is nothing but string. Check first two elements are AB or not. If it is, just make count plus one, maintain a variable count plus one. Go to next element, just check these two, the first two letters. The first letter, but why what I mean is the number of letters you have in the PS itself. Yes. When you move next, BAP also does not have first two letters as matching. Bad does not have, is it right? So in this case, you were able to increment only once. So answer will be one. So in this, we are saying try to match every single word with PS, is it right?
Yes.
Or to be more specific, just check initial two letters for every single query. So in this, what we are saying is check all strings. In one mode, you have if I have to tell this approach, check all strings, is it right? So time complexity wise, what would the time complexity be? If there is an array, let's say array is of size n. What could the time complexity here?
N into Q.
Yes. All the n strings we are searching, is that right? But it will not be just n here. Yes, because we are checking characters here. You should understand one thing. When you do 1 double equal to 1, when you compare two numbers, time complexity is O of 1, that is for sure. But when you compare two strings, time complexity in this is not O of 1. Is that right? String comparison is never O of 1 operation. It is always number of characters you have in those strings. Yes. So if I assume PS is of length m, yes, because those many characters will be checking, is it right? If PS has two characters, we'll be checking only two characters. If it has three, we'll be checking only three. So that means time complexity will be n into m. Is that right? For just one query. If there are q queries, it will be q into n into m. It should not be any confusion for anyone. Yes, if there are q queries, this is what the time complexity will be. And of course, we know this is disastrous. Is it right? No matter how much, how low constraints do we have, this is not acceptable at all. Yes, so we should be optimizing it. We should be coming up with some better approach, which will be optimizing this uptime complexity at least. And for that, we'll be using one data structure which will make our job easy. And that data structure we are calling as trie. Yes, purpose of trie, if you have to understand for this example, it will make string searching optimal. Its purpose, string searching is optimal. This is what is optimal. This is what we want, is that right? Because time complexity, if it was just n also, it would have been enough. Yes, but we are checking for every single character. If you could somehow get rid of those extra parameters where we don't have to check entire strings, yes, that would be the best case scenario for us, and that is what we're trying to build. So what we're doing is we are assuming trie data structure will help us to optimize our string search. This is our assumption, is that right? For that, just believe me that it will be optimal. What you have to do is first build a trie. Once you have built, searching will be optimal. So first we have to focus. If you have a set of string, if you have an array of string, how will you build a trie first? Using that trie, string searching will be optimal for sure. Is that right? So first focus, let us shift our focus to a sub problem where we are actually looking at how can you build a trie. Yes. Now trie is nothing but data structure case. Yes, it is nothing but data structure. Similar to tree itself, we'll try to correlate this trie data structure with a binary tree, which we are more familiar with. Now, what is a binary tree structure? Every binary tree has a node. Every node has what structure is?
Left and right side.
It has a left child for sure. It has a right child, and it also has one data member or integer variable. Is that right?
Yes.
Yes. So, what are the types of these left and right?
Tree node.
Whatever the node type is, if I say class name is node, it will also be of node type. It will also be a node type, and data will be of integer type. Because if this is a node, its left pointer should also point to a node. Is that right? 2 is a node. That means left is pointing to a node and right is also pointing to a node. This is what the structure of binary tree is. Is that right?
Mhm.
Structure of trie is almost similar, but just that it will not have only two children. Yes, it will not have only two children. The structure is, we are trying to just correlate with binary tree and trie. Structure of trie, let me write it. Structure of trie. And do not forget, we are focusing on the question that we are solving. Okay. So we are saying structure of trie is this. There is a class named as trie. This class will have 26 children. And we cannot have 26 variables, right? So what we'll say, we just maintain a variable, just maintain an array for that instead. Yes. Now, of course, if every children of binary tree class is node, its children will also be of trie type. Is it right? Because that will also be the same thing. In this, will not have data, but just be with me. What I'm saying is, here we'll have one additional variable called as ended, which is a Boolean type. Yes. Now, we have wrote the class. To initialize them, we should write a constructor. I'll simply set child. To initialize it, we'll need a new trie where we are saying it will have 26 children. You'll know why we are having 26 children. And of course, ended we are saying initially will be false. You'll also know what's the purpose of this ended as well in just a while. Yes, this was the structure of trie is. Just focus here. Is it right? Just keep this in mind. You'll know what exactly why these are required. Now, structure of trie is clear. Let's come back to the first step, build a trie. If you have to build a trie, we have to go to every single word of the array. Is that right? A, B, C. I'm saying there are multiple words. For now, I'm focusing on just one word, A, B, C. If you have to build a trie, we have to insert every single word one by one. Now, what we'll do is in every single tree also, there is one start point for tree. What is a start point? Where will the tree starting from? It's a root. That means trie should also have a root. It should have start point. Our trie should be having a root. And we know as this is a trie, it will have two members. One member is nothing but ended, which is initially false, is that right? And another member is nothing but an array of size 26. Indexes I'm writing 0, 1, 2, 3, 4, 5, 6. This is nothing but child. Yes, I'm removing this just to avoid any confusion. Give me 1 minute. No, this is where we are currently at. So what we'll do is, as we are focusing on the first word, we are trying to insert the first word. Let's go character by character. Yes, let's go character by character. And these cells, if you initialize, guys, if you initialize your children array with new trie, what are the default values filled in the cell? What are default value fill in the cell before we do anything?
Empty.
It will be null simply because at least when you code in Java, all the types of the class are default null. Is it right? Now, if you have to insert something, is it right? If you have to insert a word, just focus on one thing, that a cell, the cell in the child array, is it right? A cell can be active or inactive. Just focus on two words. It can be active or inactive. Inactive by what I mean, it is null simply. Yes, so by default, all the cells are inactive. Till this point, are we clear? Okay. Now, when we try to insert the word, you'll see the first character is A. Is that right? The first character is A. So what you'll do, as we have to make string searching optimal, we simply have to insert it. To simply insert A, what you'll do, from root, there is a word starting from A. And we are saying A simply represents the 0th index. B will simply represent the 1th index. So on, Z will simply represent 25th index. Yes, that means every single character, if it is lowercase, we are able to map it in this array. Is that right? So now, As we are at the first character A, we'll say make this cell as active. The first cell is active. What do you mean by active? That means it is not null. If it is not null, what do you mean? From here, there is one more node coming out, which is nothing but try itself. We are making one more node of try. Yes. Again, in this also, there are two variables ended, which is initially false. And in this also, we have an array itself. Is it right? I'm not writing a variable name. Just imagine they are. Okay. Now, first character is inserted, guys. When second character is there, B, what do you think we should be doing?
Go and mark.
Yes. Yes. Now this node is nothing but Eka node. Is that right? If you have to continue inserting it in eighth node, you should specify after A there is one more character B which is actually active. Yes. If it is active, I'm just shading it with the black pen or red pen, anything. Now B is active. That means it is not null value. If it is not null, we'll have to put something in there. This is where I'll say one more node I have created this time, which is continuing the B wala node. And here also, this time what I'll do, I'll say C is the node that is active. Yes. Now, once you do this, you should also specify Cth node is not active. Is that right? That means it is there. A is there, B is there, C is there. If you just have to mention what has ended, what you'll do, you'll again create a new node. You will create a new node. You will not make any cell active. All the cells are inactive. All the cells are none. But change you will do is with the ended variable. Yes, at this particular point, you should understand that here, if starting from root, there is one A which is active. If you go to A wala array, you will see the second word B is active. If you go to B wala array, you will check Cth word is active. If you go to C wala array, you will say the first member, the first child, the first member of the class which is ended is true. What is it specifying, guys?
So
Yes.
first and
Yes, it is just specifying that one word has ended here. Is it right? Just one word has ended here. Now, just make you understand, I'm trying to insert one more word and see what will happen. I'm trying to insert A, B, E, guys. Think about it for a while and see what will happen here.
J is already active.
Yes. So from the root, we are trying to insert first character A, and you check A is already active. Is it right? We don't have to do anything. You will go to Bth node of A, that is already active. What is the next character? It is C. In B, you will check is the Eth node active? Answer is no. Is it right? Answer is no. So what you will do? From here, you will create one more node, which is nothing but similar to last node. This time also it will be true, and everything else will be inactive. Yes, are you able to visualize this?
Yes.
Yes, great. Now, okay, so drawing these nodes are hectic, so I'll make a shortcut and see if I can try to visualize the entire array. Now, if string building is clear, there are two words ABE, ABC. Okay, let me take one more word, BACK. Yes, this is the root, is that right? I'm not drawing those dabba now, just we try to visualize. From this, there is A. Yes, from there will be an A wala node. From A wala node, you'll go to B wala node. Is that right? This is just like this, guys. Is that right? I'm just eliminating, writing those boxes here. From B, what will happen? From B, there is one more node to C. Yes, and from B, there is one more node to C. Sorry, to E. Of course, after there, it is one more node. There is nothing here, but only thing is you'll true. You'll make that ended as true. That is it. From here also, there is one more node, but here everything is null, but you will simply say ended is true here. Yes, from here, A path is done. Now you'll also insert B, A, C, and K. Of course, after this, you'll just make ended equal to true. And remember, every single node has ended, but by default, those are false. Yes, because we did not change anything, those will be false itself. Yes?
Yes.
Okay, sure. So I'm not writing this, but you should understand there are. Now, I have inserted, is that right? Our first focus was to build a try. Let's say building try is done, at least visually, at least dry running wise, we have built a try. Now, if I ask you query, guys, if I ask you query PS, which is nothing but A, what do you think we can do? What do you think we can do with this try to make our string searching optimal?
We can go to A.
Yes.
From there, we can see how many ended.
Yes. So the first advantage this approach, this try build is giving us is, do we need to go in this direction, guys? Answer is no, because simply say in the root array, right? In the root array, you simply need to go to eighth map. You don't even need to go to any other map which is not passing through A. So that means at least this part we have eliminated. The B wala part we have eliminated. So in this, what you need to do, come at a point where you are currently at A. Yes, you are currently at here. So how can you search it now? Just using this try, how can you know how many words are there which are starting from A now?
Go to
Yes.
the node.
Yes.
So
So now it should make sense to everyone. Just we need to go to all the directions below it, and we just need to check how many nodes are there who have ended as two. Yes, if you just count this, how many nodes are there who have ended as two, that will be your final answer.
yes.
So it's just about recursion, going widely in all the directions and just counting how many nodes have ended as two. Yes. Now, but still, we did not optimize anything. Do you agree?
Yes.
Yes. If you think that this is the string, I'm changing a bit. Is it right? This is the string. So what will happen? This B is not coming from root now. It is also coming from A.
Yes.
Yes. Now, if I ask you A, in this case also we'll be checking entire strings. Is that right? In this case also, as I said, we have to start from A. You will come at here. You are going to all the nodes below it. It is nothing but you're checking all the strings. Yes. So time complexity in this is also not changing, guys. It is also n into m for all the queries. Yes. So how can we optimize it? It is very simple. Yes. Now, give me 1 minute. Till then, if you have any thoughts, how can you optimize it? I'd like to hear. No? Okay. Yeah. So this structure of trie, this is a default structure, is it right? This helped us to at least keep track of how many nodes, how many strings we have inserted, and how many strings are ended. In this, I am bringing one more variable, which is nothing but visited. Yes, and of course, I'll have to initialize it. I will make it to 0 and see what is the job for this. Is that right? Okay. So as we were trying to know what we can do with this visited member, is it right? We said this will help us to optimize our string searching. Let us see. Let's come back to the point that where we were inserting this. Yes. While inserting, I'll say whenever I insert A, right, I'll say visited equal to 1. That means I have visited this A for the first time. I'll insert B. I'll say visited equal to 1 again. I'll insert E. I'll also say visited equal to 1 whenever I come to an ended. Is that right? This is the point you should also mention that this part, this word has ended here, and this node I have visited for the first time. Yes, and this part is done. First string insertion is done. Let's try to insert C. This is where the things will get interesting. The first character is A. You are currently at A. A is already there. So what you should specify just, I have visited this for the second time. Is that right? When you come to insert B, B is already there. You should just mention, I have inserted B for the second time. You'll insert next character C and you'll say, I have visited C for the first time. As it is ended, you'll also create an ended node where you'll say, I have visited this for the first time. And same thing will happen for back also. Is that right? Let me fast forward it quickly. So where B will be inserted, A will be inserted, C will be inserted, K will be inserted, and this is nothing but ended. In everything, B will be one itself. Yes. Now, let's come back to our query now. When I said PS is equal to A, the optimization is still there, is that right? This part we don't even need to worry about because B part we don't even need to go to. We'll come to the first A index of the root array. We'll come to eighth index, means zeroth index of root array. First question, do we need to traverse entire nodes below it, guys? No. Answer is no. Is that right? We don't even need to traverse entire nodes below it. And how we can say, why do we don't want to traverse all the nodes? Why do we don't want to traverse all the nodes below A this time?
We already have the count.
Yes. The variable that is there, VIS, it will help us to answer directly here, then and there itself. Is that right? What is this specifying? It is specifying number of nodes I have visited, number of nodes I have inserted were only two from this part. Is that right? Number of strings that I have inserted from A were only two. That means you will just come at A wala point. From root, you will come to A wala point, and whatever the visit value was there at that point, you will simply say that is itself your answer. Yes. Now, if I change one more query, guys, if I say query is A and B, what do we need to do here?
We need to go to B.
Yes.
C.
Yes. So from root, you will come to first A wala point. From A, you will go to B wala point. At B, whatever the visited value is, that will be your answer. Yes, and that is making sense also. Is that right? That means while inserting ABE, B was visited once. While inserting ABC, B was visited twice. Yes, in total it is visited only twice. So that means answer will be 2. Next. Okay, so this is what optimization we did. Now, seeing this, what do you think the time complexity is? Now,
This will be n into if we say n,
just for answering the query, what could be the time complexity?
uh, maybe the length of the string.
Yes. So in this, if PS was of length 2, is that right? What did we do? We came here, we came here. That means we made two iterations. If it was 3 length, what we'll do? We'll come to a point where the string has ended. Simply for answering every single query, what are we doing? We are going to route to A to B, and B to next character if it is there running. So simply, can we simply say time complexity is just M now? Because we are traversing only M nodes below to reach at a point from where we can answer directly. And for every query, we are just taking Q into M only.
Yes.
Previously, our time complexity was N into M into Q. Now we have brought it down to just M into Q, which is acceptable. Is that right? This time complexity takes just for reading only. Yes, so this is acceptable. Now, so trie data structure stands on this behalf that you have to build a trie. After that, string searching will be optimal. Is it right? But there are many more things we can do with trie. And there is one thing that you should be hearing or you should be using more oftenly. That is Google search. Yes, let's say we are searching something, guys. Ignore my spelling. Google search. If I'm searching something, let's say ACTI. Yes, if I type these 4 letters in Google, what can you see as suggestions as? I can see Activa. I can see active
Acting.
acting, or I can see actively. That means all the words which are starting from ACTI are going to be my suggestions.
Yes.
Yes, can we implement the same functionality using trie also? Just theory wise, we can. Is it right? And this is what we did, where we said A, B is a start point. What we need to do? Come at B point. All the nodes below this, wherever ended is true, that will become your one of the word. But that will become one of your suggestions. Is it right? Imagine if PS was AB only. What you will do from AB, how many nodes are there below AB? Just traverse all the nodes. Yes, and wherever you find ended equal to 2, that means that is one of your word. That is one of your valid word that you can suggest. Is it right? That means ABE is one of your word. ABC is one of your word.
Correct.
Yes. So trie is also used not only in string optimization, so or string searching optimization, it is also used in auto completion or auto selection. Yes.
Yes.
So basically, this is what the fund of trie is. So first thing we'll be doing is inserting. Second thing we'll be doing is searching or getting the prefix, whatever it is.